The last two problems on this first lesson just ask you to actually create your own curve using a set mean and standard deviation. So in this case, we're going to draw our own normal curve where the mean is 60 and the standard deviation is 7. And it tells us it's normally distributed, so we can go ahead and draw the normal curve. So just a reminder, right in the middle should be your mean, and then you always go 3 to the right, 3 to the left from there. And we've got, so this next one would be 67, because I'm going to add 7, or add the standard deviation. And then I'll just keep adding 7, so this will be 74. And this last one would be 81. To go the other direction, we are going to subtract 7. So we'll have 53, and then 46, and then 39. The percents that we had earlier will all stay the same though. So this is still 34%. This one's still 13.5. I'm just going to write them really quick. This one's still 2.35. And then we've got our 0.15%. All right, that'll make our life really easy. So, perfect, just double checking. So we are just doing these 3 right here with number 9. And notice the wording tells us probability, so make sure it's not in terms of a percent, but a decimal. So we are going to go ahead and find the probability that it's between 53 and 74, so right here. So this section in between, which would just be 34 plus 34 plus 13.5. So you get the 81.5%. But we need to write it as a probability, so we'll put it as 0.815. Let's go ahead to our next one. So for the next one, we are going at least 67. So here's 67. So if we're going at least, that doesn't mean we want something smaller. We want things that are bigger. So 67 or bigger is another way to say at least 67. So in that case, we're going to take that 13.5, add it to the 2.35 and the 0.15, which is 16%. Once again, since it says probability, change it to a decimal. Last one on this problem, at least. So the next one tells us we want to be at most 60. So we find 60. At most 60 just means you don't want to go any bigger, so anything less than 60. 60 or below. And since it's right in the middle, if you remember, the middle is always where, because it's symmetric, that actually tells us you'll have 50% of your data below and then also 50% above. So the probability would be 0.50 or just 0.5. So you can also add all those up, and if you don't believe me, it will add up to 50%. Let's do one more of those just to get that under our belt. So we've got a normal curve on this problem. We draw a really good picture like I just did, and you put the mean in the middle, and you're going to go 3 out on both directions. And the standard deviation is 2, so you're going to add 2, so you get 46, 48, and wow, 50. And then you're going to subtract 2 the other direction, so 42, 40, and 38. And all those percentages stay the same. So we've got 34, 13.5, 2.35, 0.15. And once again, the wording says probability, so those are all the percentages, so we're going to have to convert after we find our answer. So we've got between 38 and 42. Between 38, and 42 right here. So for this problem, we're just going to go ahead and add those two in between. So we've got 2.35 plus 13.5, which is 15.85%, or because it's probability, the probability is 0.1585. All right, let's go to the next one. So now we're going to at least 40. So here's 40. So at least, remember, means 40 and above. Now that's a lot of things to add. So a quick trick, if you don't want to have to add all those, I'm going to go ahead and take the two that are remaining and subtract them from 100, or the two that are not included, I should say. So I'll subtract both of those from 100, and you get 97.5%, or 0.975. Perfect. That was so fun. It's the most fun, actually. So 46, at most 46, last one we're going to do. So here's 46. So at most means anything below 46, 46 and below, I should say. And once again, there are only 3 that are not included, so I'm just going to do a little quick trick by subtracting those 3, which is 90, or not 90, wow, 84%. And if you convert that to a probability, like it asks, you get 0.84.